The physical exploration of the Moon began when Lunar 2, a space probe launched by the Soviet Union, made an impact on the surface of the Moon on September 14, 1959. Prior to that, the only available means of exploration had been observation from Earth. The invention of the optical telescope brought about the first leap in the quality of lunar observations. Galileo Galilei is generally credited as the first person to use a telescope for astronomical purposes, having made his own telescope in 1609. The mountains and craters on the lunar surface were among his first observations using it. NASA's Apollo program was the first, and to date only, mission to successfully land humans on the Moon. The first landing took place in 1969, when astronauts placed scientific instruments and returned lunar samples to Earth. Early history. The ancient Greek philosopher Anaxagoras reasoned that the Sun and Moon were both giant spherical rocks, and that the latter reflected the light of the former. His non-religious view of the heavens was one cause for his imprisonment and eventual exile. In his little book On the Face in the Moon's Orb, Plutarch suggested that the Moon had deep recesses in which the light of the Sun did not reach, and that the spots are nothing but the shadows of rivers or deep chasms. He also entertained the possibility that the Moon was inhabited. Aristarchus went a step further and computed the distance from Earth, together with its size, obtaining a value of 20 times the Earth radius for the distance. Although the Chinese of the Han dynasty believed the Moon to be energy equated to qi, their radiating influence theory recognized that the light of the Moon was merely a reflection of the Sun. This was supported by mainstream thinkers such as Jing Fang, who noted the sphericity of the Moon. Shen Kuo of the Song dynasty created an allegory equating the waxing and waning of the Moon to a round ball of reflective silver that, when doused with white powder and viewed from the side, would appear to be a crescent. By 499 AD, the Indian astronomer Aryabhata mentioned in his Aryabhata that reflected sunlight as the cause behind the shining of the Moon. Habash al-Hisab al-Marwazi, a Persian astronomer, conducted various observations at the Al-Shamsiyya Observatory in Baghdad between 825 and 835 AD. Using these observations, he estimated the Moon's diameter as 3,037 kilometers and its distance from the Earth as 215,209 miles, which come close to the currently accepted values. In the 11th century, the Islamic physicist Al-Hasan investigated moonlight, which he proved through experimentation originates from sunlight, and correctly concluded that it emits light from those portions of its surface which the sun's light strikes. By the Middle Ages, before the invention of the telescope, an increasing number of people began to recognize the Moon as a sphere, though many believed that it was perfectly smooth. In 1609, Galileo Galilei drew one of the first telescopic drawings of the Moon in his book Sidereus Nuncius, and noted that it was not smooth but had mountains and craters. Later in the 17th century, Giovanni Battista Riccioli and Francesco Maria Grimaldi drew a map of the Moon and gave many craters the names they still have today. On maps, the dark parts of the Moon's surface were called Maria Seas, and the light parts were called Terrea continents. Thomas Harriot, as well as Galilei, drew the first telescopic representation of the Moon and observed it for several years. His drawings, however, remained unpublished. The first map of the Moon was made by the Belgian cosmographer and astronomer Michael Florent van Langren in 1645. 2 years later, a much more influential effort was published by Johannes Hevelius. In 1647, Hevelius published Selenographia, the first treatise entirely devoted to the Moon. Hevelius's nomenclature, although used in Protestant countries until the 18th century, was replaced by the system published in 1651 by the Jesuit astronomer Giovanni Battista Riccioli, who gave the large naked eye spots the names of seas and the telescopic spots the name of philosophers and astronomers. In 1753 the Croatian Jesuit and astronomer Roger Joseph Bošković discovered the absence of atmosphere on the Moon. In 1824 Franz von Grüthuisen explained the formation of craters as a result of meteorite strikes. The possibility that the Moon contains vegetation and is inhabited by selenites was seriously considered by major astronomers even into the first decades of the 19th century. In 1834 to 1836, Wilhelm Beer and Johann Heinrich Madler published the 4-volume Mappa Selenographica and the book Der Mond in 1837, which firmly established the conclusion that the Moon has no bodies of water nor any appreciable atmosphere. Space race. The Cold War-inspired space race and moon race between the Soviet Union and the United States of America accelerated with a focus on the Moon. This included many scientifically important firsts, such as the first photographs of the then unseen far side of the Moon in 1959 by the Soviet Union, and culminated with the landing of the first humans on the Moon in 1969. Widely seen around the world as one of the pivotal events of the 20th century, and indeed of human history in general. The first man-made object to reach the Moon was the unmanned Soviet probe Lunar 2, which made a hard landing on September 14, 1959, at 21 hours 2 minutes and 24 seconds Z. The far side of the Moon was first photographed on October 7, 1959 by the Soviet probe Lunar 3. Though vague by today's standards, the photos showed that the far side of the Moon almost completely lacked Maria. In an effort to compete with these Soviet successes, U.S. President John F. Kennedy proposed the national goal of landing a human on the Moon. Speaking to a joint session of Congress on May 25, 1961, he said, "First, I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the Moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind, or more important for the long-range exploration of space." The Soviets nonetheless remained in the lead for some time. Luna 9 was the first probe to soft land on the Moon and transmit pictures from the lunar surface on February 3, 1966. It was proven that a lunar lander would not sink into a thick layer of dust, as had been feared. The first artificial satellite of the Moon was the Soviet probe Luna 10, launched March 31, 1966. On December 24, 1968, the crew of Apollo 8, Frank Borman, James Lovell and William Anders, became the first human beings to enter lunar orbit and see the far side of the Moon in person. Humans first landed on the Moon on July 20, 1969. The first human to walk on the lunar surface was Neil Armstrong, commander of the U.S. mission Apollo 11. The first robot lunar rover to land on the Moon was the Soviet vessel Lunokhod-1 on November 17, 1970 as part of the Lunokhod program. To date, the last human to stand on the Moon was Eugene Cernan, who as part of the mission Apollo 17, walked on the Moon in December 1972. See also, a full list of lunar Apollo astronauts. Moon rock samples were brought back to Earth by 3 lunar missions and the Apollo missions 11 through 17. For the mid-1960s to the mid-1970s there were 65 moon landings, but after Lunar 24 in 1976 they suddenly stopped. The Soviet Union started focusing on Venus and space stations, and the US on Mars and beyond, and on the Skylab and Space Shuttle programs. Before the moon race, the US had 3 projects for scientific and military moon bases: the LUNEX project and Project Horizon. Besides manned landings, the abandoned Soviet manned lunar programs included the building of a multi-purpose moon base, Zvezda, the first detailed project, complete with developed mock-ups of expedition vehicles and surface modules. Recent exploration. In 1990, Japan visited the Moon with the Hayaten spacecraft, becoming the 3rd country to place an object in orbit around the Moon. The spacecraft released the Hagoromo probe into lunar orbit, but the transmitter failed, thereby preventing further scientific use of the mission. In September 2007, Japan launched the Selene spacecraft, with the objectives to obtain scientific data of the lunar origin and evolution and to develop the technology for the future lunar exploration. According to the JAXA official website, the European Space Agency launched a small, low-cost lunar orbital probe called SMART-1 on September 27, 2003. SMART-1's primary goal was to take 3-dimensional X-ray and infrared imagery of the lunar surface. SMART-1 entered lunar orbit on November 15, 2004 and continued to make observations until September 3, 2006, when it was intentionally crashed into the lunar surface in order to study the impact plume. China has begun the Chinese Lunar Exploration Program for exploring the Moon and is investigating the prospect of lunar mining, specifically looking for the isotope helium-3 for use as an energy source on Earth. China launched the Chang'e-1 robotic lunar orbiter on October 24, 2007. Originally planned for a 1-year mission, the Chang'e-1 mission was very successful and ended up being extended for another 4 months. On March 1, 2009, Chang'e-1 was intentionally impacted on the lunar surface, completing the 16-month mission. On October 1, 2010, China launched the Chang'e-2 lunar orbiter. China landed the rover Chang'e-3 on the Moon on December 14, 2013, became the 3rd country to have done so. Chang'e-3 is the first spacecraft to soft land on lunar surface since Lunar 24 in 1976. India's National Space Agency, Indian Space Research Organisation, launched Chandrayaan-1, an unmanned lunar orbiter, on October 22, 2008. The lunar probe was originally intended to orbit the Moon for 2 years, with scientific objectives to prepare a 3-dimensional atlas of the near and far side of the Moon and to conduct a chemical and mineralogical mapping of the lunar surface. The unmanned Moon Impact Probe landed on the Moon at 15:04 GMT on November 14, 2008, making India the 4th country to touch down on the lunar surface. Among its many achievements was the discovery of the widespread presence of water molecules in lunar soil. The Ballistic Missile Defense Organization and NASA launched the Clementine mission in 1994, and Lunar Prospector in 1998. NASA launched the Lunar Reconnaissance Orbiter on June 18, 2009, which has collected imagery of the Moon's surface. It also carried the Lunar Crater Observation and Sensing Satellite, which investigated the possible existence of water in Cabeus crater. GRAIL is another mission, launched in 2011. The first commercial mission to the Moon was accomplished by the Manfred Memorial Moon Mission, led by Lux Space, an affiliate of German OHB AG. The 4M spacecraft made a moon flyby on the night of the 28th of October 2014, after which it entered elliptical Earth orbit, exceeding its designed lifetime by 4 times. Plans. Following the abandoned U.S. Constellation program, plans for manned flights followed by moon bases were declared by Russia, Europe, China, Japan and India. All of them intend to continue the exploration of Moon with more unmanned spacecraft. China plans to conduct a sample return mission with its Chang'e 5 spacecraft in 2017. India expects to launch another lunar mission by 2016, which would place a motorized rover on the Moon. Japanese Aerospace Exploration Agency plans a manned lunar landing around 2020 that would lead to a manned lunar base by 2030. However, there is no budget yet for this project and the plan reverts to robotic missions. Russia also announced to resume its previously frozen project Lunar Glob, an unmanned lander and orbiter, which is slated to launch in 2016. In 2015, Roscosmos stated that Russia plans to place an astronaut on the Moon by 2030, leaving Mars to NASA. The purpose is to work jointly with NASA and avoid a space race. Germany also announced in March 2007 that it would launch a national lunar orbiter, LEO, in 2012. However, the mission was cancelled due to budgetary constraints. In August 2007, NASA stated that all future missions and explorations of the Moon will be done entirely using the metric system. This was done to improve cooperation with space agencies of other countries which already use the metric system. The European Space Agency has also announced its intention to send a manned mission to the Moon, as part of the Aurora program. In September 2010, the agency introduced a lunar lander program with a target of autonomous mission to the Moon in 2018. On September 13, 2007, the X Prize Foundation, in concert with Google, Inc., announced the Google Lunar X Prize. This contest requires competitors to land a privately funded robotic rover on the Moon that is capable of completing several mission objectives, including roaming the lunar surface for at least 500 meters and sending video, images and data back to the Earth. In March 2014, SpaceX indicated that while the current focus is not on lunar space transport, they will consider commercial launch contracts for one-off Moon missions. Timeline of Moon exploration.